the magic numbers e, d, and n.
Greg, RSA works perfectly with the keys you have generated. So, what's special about the numbers e, d, and n used for the keys?
Yes, these numbers, e, d, n, have some special properties. Property 1. The number n has two prime factors. Prime factorization is finding which prime numbers multiply together to make the number n. For example, the prime factors of 211 are 13 and 17, where 13 and 17 are prime numbers. Actually, we can use Sage Math to compute n the prime factors for the number 221. Here, we can easily verify the two factors 13 and 17 are prime numbers. Property 2. If phi is the number of coprimes of n, then e multiples d, and modulos the results by the phi equals 1.
Greg, how to compute the number of coprimes of n?
To calculate the number of coprimes to 6, we list all the positive numbers less than 6, and then compute the greatest common divisor for each number in 6. We simply count the number of ones for the greatest common divisor results. Therefore, the number of coprimes to 6 is 2.
Greg, I can verify the property 2 using Sage. Assume n equals 6, a simple for loop can easily calculate the number of coprimes to n, that is, phi, then, I can verify 5 times 77 modulo 2 equals 1.
Property 3. If the number n has two prime factors, p and q, then the multiplication of p-1 and q-1 equals the number of coprimes to n. For example, the number 6 has two prime factors, 2 and 3, then the multiplication of 2-1 and 3-1 equals the number of coprimes to 6, which equals 2.
The formula is a simple example of Euler's phi function. Euler's phi function is a simple way to count the positive integers up to a given integer that relative prime to the given integer. The function is named after me.
Let me verify the Euler's phi function using Sage with the number 211.
First, I compute the prime factors of 211, which is 13 and 17, then I count the number of coprimes to 211, which returns 192. Finally, the statement verifies the phi function.
Property 4. To find the number of coprimes of large number, using my Euler's phi function is much faster than the brute force algorithm.
I1. Euler's function is the fastest method to find the number of coprimes to a given large number.
Can you find the number of coprimes to the large number using Sage?